Okay, so these are the types of skills that the Algebra II final is going to require you to know how to do. All right, the first is binomial multiplication. Now, almost all of you would ace that if that was the only thing. All right, you're going to multiply these two, and if you remember, one of the things that I stress is that the first numbers are one and done. The last numbers are one and done. So when you have a trinomial and you're trying to factor it back into the binomials, what you look for is a prime number as the coefficient in the front or the coefficient in the back, so that you know there's only one way to break it apart. All right, but binomial multiplication, you're going to see it and, oh good, I got that one. Okay? All right, now, there's also quadratic factoring. That's what we're talking about here. Now, when you see this 3x squared, what does that tell you? What's the only way to break apart 3x squared?
1 and
3x and 1x, right? And so you're going to have 3x and 1x, and then you're going to have to figure out how the 8 was multiplied together so that when you do inside-outside, you get 5. All right, that's the type of thing that, again, have we been doing this a long time? Are you an expert at it? Well, we'll find out, right? But you should be good at it, right? Okay, now, the third type of factoring is the cubic factoring. Now, I have put two examples on this handout that show a hard cubic factoring problem. So that, because if it's just x and y, or x cubed and y cubed, when you're factoring it, you're not looking at the numbers, you're just looking at the exponents. Okay? And so this has a number in here. Now, this is 8x cubed. If this is 2x to the first power, what do I have to multiply it by in order to end up with 8x cubed? A 4 as well as an x squared. That's why that first number here is 4x squared. Because if I don't do first this times this, I can't get that. Right? Make sense? And that same thing in this case would be true for 27y cubed. Right? If this is 3y, because it's the cube root of both of those, then 3y times what is 27y. 3y times 9 here to make 27. You see that?
Yeah.
Okay, so, and then if this is plus, this is minus, now the middle is going to be this times this. So that's why it's 6xy. Okay. But what's wrong with this is that y squared times 3y is only 3y, not 27y. So you've got to be careful if you have that problem. All right, here's another example. All right, what's 125 is what cubed? What cubed is 125? If I say 5, 5. So I have a 5x here and then 5 squared here. All right, a third of this is how many? 4. All right, and then 2 4s is 8. And now when I multiply 5 times 25, I get 125. x4, x8 is x12. Now, that's not as hard as the problem you're going to see on your test. So don't freak out over this last one. But you should be able to understand how to do that. Because if you can understand that, then that means you got this skill down.
Wait, that's not as hard as what's going to be on our test?
This is not as hard. No, it'd be much easier than this problem.
That's way harder than
This one is way harder than the problem you're going to have on the test. You don't have to do that deep, but you should understand it that deep. Okay. All right. Now, all right. Let's look at the next one here. All right. Domain and range. All right. X's such that the set of x's that x is greater than -3, x is less than or equal to 1. But see how I did that? Mm-hmm. All right, the y is such that y is greater than -4, y is less than 0. Now, why does this one have one equal and one not equal? Open circle, closed circle. Then if you're looking at the y, then the greater part does not equal 0, it only approaches 0. Okay, and then these things are for practice if you haven't already looked at those. Okay, now, graph the absolute value on a number line. Come on in. Oh, you can't come in because it's locked. Okay, all right. Okay, sorry. I thought that was rude. Okay, so how do you do absolute value? What's the first thing you have to do in my class to be able to make an absolute value equation? Okay, you should know this.
Multiply the other side by the opposite.
That's right. That's right. We're going to copy this sign over here and then put a -5 on the other side. Because the absolute value could have been positive, could have been negative. All right. Now, after you do that, then you're going to do what to eliminate this? Add 3 to all 3 parts. And then you're going to divide by 2. And because I was dividing by +2, the signs don't flip. If I wanted to be really mean, I would have had a negative here so that you would have had to flip the signs. Again, is that new material? No, but that will be, you'll be tested on that. All right. Okay, determining solutions for linear equations. All right, if you have this, how do you find b if that point is part of the equation? Starts with the r. The skill is you replace the x and the y in this, so you end up with 6 minus 20. If I replace the 2 and the 4, 6 minus 20, and so the b is going to be what? -14. You don't have a choice. You got a calculator to be able to get the answer, but you have to know to replace it. 3 times 2 minus 5 times 4. Now, what happens in this one? How do you find b? You still have to replace. Only in this case, the 6 goes here and the 9 goes here. So if I put the 6 here, 6 divided by 3 is 2. 2 times this 2 is 4. 4 plus some number has to equal 9. B ought to be 5. Right? So, when you're determining solutions of linear equations, when you find a point on the line, you take the equation and you substitute. You replace the values of x and y and find the remaining variable. Okay? Now, also in that regard to linear, you're going to have to transform a linear into slope-intercept. Shouldn't have to talk too much about that because this goes to the other side as this term goes to the other side of the equation as what? What are you going to have to add? Where'd it go here? It moved. It moved. There it goes. Okay. What are we going to have to add to this to make 0? -4x. And when I add a -4x to this side, what do I have to do over here? Add a -4x. So when this number goes to the other side, it changes sign from +4x to -4x. This past week, I have a 7th grader that's taking algebra, and that's one of the skills that we talked about. Right? So this goes to the other side. So now, when I do that, then I'm going to have to also divide by -2. So negative 4 divided by negative 2 is positive. Had this been a plus, my sign would have been negative 4 divided by positive, which would have been negative, whatever the two numbers were. And now, what did I divide by? Negative 2. What is negative 10 divided by negative 2? 5. Positive 5, right? So my intercept is going to be at plus 5. If we were graphing it, we'd go up 5, put a dot, and then we'd go up 2 over 1, up 2 over 1. And we graph it. Again, is that Algebra 2? No, that's Algebra 1. But it's things that you have to remember from Algebra 1. Okay? So, and for people that are wondering, there's the steps. Alright, now, function notation. What is f of 4? 11 times 4 plus 2. 44 plus 2, 46. Alright, what did you do? You replace the x with a 4. Okay, what does this say to do? Replace the x in g with f of negative 1. So what is f of negative 1? This negative 11 plus 2, which is negative 9. And then I put a negative 9 in here.
18.
Negative 18. So g of f of negative 1 would be that. Now what is this one? This says replace the x in f with g of 2. So what is g of 2? 4. And I put the 4 in here.
46.
Right? 44 plus 2, 46. Okay. Right? Not mystery, you just have to know that's what it is. Okay? Alright, now, I believe that you are going to have to demonstrate you understand Kramers Rule. What happened to my markers?
I remember the book.
There we are. Okay. All right. Now, so Kramers Rule starts with the equation. That's what I'm going to remind you of. Kramers Rule starts with the equation. The bottom denominator of the x and the y solution is this. So you're going to take the diagonal down, 1 times 1, 1 times negative 1, and then you're going to take minus the diagonal up. So negative 1 minus 1 is negative 2. So both of the denominators have negative 2. All right? Now, to be able to get the x, what do you do in Kramers Rule? And again, we are back to replace the answers with the x. So now I'm going to have 3, 5, and 1, negative 1. Okay, so the numerator will be negative 3 minus 5, which is negative 8. So what is negative 4 divided by negative 8? I'm sorry, negative 8 divided by negative 2 is 4. So that means my x value is 4. Now, for the y value, we replace. Were we doing this one? Okay, we're doing this one, right?
Yeah.
We replace this is 1 and 1, and now this is 3 and 5. So I go 5, subtract 3, which is 2. And what is 2 divided by negative 2? Negative 1. Okay? So I have 4, negative 1 as the solution. Okay? Alright, so let's see if we can do this other one. Okay? Start. What is the denominator? Denominator is negative 1 minus negative 2. Negative 1 minus negative 2 is 1. So I have that. Then what do you do next? Replace the 4 and the 6 and keep the -1, -1. And so now I have -4 minus -6, which is +2. All right, you're not very enthusiastic. All right, and then for this one, I keep the 1 and the 2, and then the 4 and the 6. And now I have 6 subtract 8, which is -2. Okay. So, if you were to write this type of information down and then the answers, that would prove to me that you understand how to use Kramers Rule. If all I see is the answers, you do not get credit for that problem. Because there are other ways to solve it. Okay? And the reason that you learn Kramers Rule is not for the ones that work out to be whole numbers, but for the ones that do not work out to be whole numbers. That's the reason that we have to learn it. Okay? All right. Solving quadratic equations. Okay. What you have here is the factors of -6 that add up to 5. The factors of 6 or -6 are 1 and 6, 2 and 3. All right, if it's the factors of -6, one of them has to be negative, one of them has to be positive. How can I end up with a +5? First of all, I can't use these two because I'm going to subtract and use the sign of the bigger number. But I can use this one. To subtract and use the sign of the bigger number, that has to be positive, that has to be negative. All right, now, because this is 2x, I also know that I have 2x and x. Now, how can I get a -1 if I start here? What 2 times 1 is what? 2. I'm already over. So therefore, this must be the -1x, and this has to be the 6x. So now, if I start at 2, how do I end up with 6? Better be a 3. Okay? If I start with 1, how do I end up with -1? And you're done. Now, if I would have had you in Algebra 1, that would be how you learn that. And we do that before we work with the other ones, because the other ones, when this is 1 squared, when this is x squared, 1x squared, then all you're doing is breaking that last number down. That's fast and easy. Right, this is the hard one. Okay. So you'll have one of those to do. If all else fails, you can always what? Use the quadratic formula. The discriminant tells you something about it. If the discriminant is 0, then you're going to have -b plus or minus 0. So you'll have a dual root, one answer that's a dual root. If the discriminant is positive, you're going to have 2 answers. If it's a perfect square, you'll have 2 rational answers. If it's not a perfect square, you'll have 2 irrational. And if it's negative, you do not have any reals, you have 2 imaginaries. Okay? So that'll all be on your test. There's more than one question about quadratics. Okay? Exponentials. Yeah. If you have a value up here and a value in the denominator, what do you have to do with the exponents? Subtract. Thank you. So I see a y here and a y here. 8 minus 3 is 5. Where? In the numerator. Okay? This says 4 minus 7, which is 3, and it'll be a positive 3 in the denominator, negative 3 if it was in the numerator. Okay? Makes sense? Now, logarithms. Logarithm, you're going to start with the exponent form. The base to the exponent equals n. Right? Now, what is a logarithm? It's an exponent. What is a logarithm? An exponent. Right? That's detestable. So that means it's on the test. Okay? Alright, so if I have this, in order to be able to change it, I'm going to take log base b of n equals the exponent. Okay? So, if I give you this, it says log base 3 of 81 equals 4. That's the change. Some equations you cannot do anything with the equation in, so you change it into a logarithm form. Alright? So let's look at some of those. Okay? Now, this is the base b, this is the exponent. If I got rid of the a by dividing, then I could say log base b of this number is equal to x, and I can solve it. Right? Because 4 equals 4 to the first, then log base 4 of 4 equals 1. And that's just part of what we learned. So, what happens if you have this? 4 to the x. If I take log base 4 of this, I'll get x. And log base 4 of this makes my two different bases. So I'll take log of 28 divided by log of 4. That's what I've tried to teach you about logarithms. That's used the most, and it's nothing but calculator work. Right? So if you start here, to be able to get at the exponent, we have to use the log. Right? And then we take a log of both sides, and then we have something we can put in the calculator. So, where's the x in this problem?
It's the base.
It's the base. So I say x to the 5th power equals 32. And then if I have this, I use the 1/5 power to get x to the first. 32 to the 1/5 power is a calculator problem where you have to use the parentheses for the exponent. Okay? Now here, where's the x?
It's the answer.
The x is the exponent, so I already can do this. This is the rule. Log 75 divided by log 5. I can use ln 75 divided by ln 5. Okay? Here, where's the x? The x is the number. Yes, ma'am?
I have a question. For the first one with the exponents and x, if you already know what the x is, can you just write the answer and really not count that?
If you can see it, I do not think you'd be penalized for just writing the answer. Okay, on the ones you can see. You can't see all of them. As opposed to Kramers Rule, where you have to prove you can use Kramers Rule. Right? But that's a good question. So, if you saw this one here, right? Now, obviously, you can't raise 4 to some power and get 28, but let's say that this was 16. Then you should know that 4 to the 2nd power is 16, so x must be 2. Right? If it was that simple or that obvious, yes, x equals 2 is all you have to write. Right? But this one, obviously, you can't because that's a different number. So that's a good question. Okay, now let's look at this one. All right, where's the x now? The x is the number, right? So we'd say 4 to the 2.5 power equals x, and then this is calculator work. All right, so we have a couple of conversions that we have to do, and we have several rules that we can do to be able to find logarithms. All right, those are Algebra II skills. They're on the test. They're not hard. Just make sure that you follow through step at a time when you get it. Okay? All right, inverse functions. Now, what do you do for an inverse function? Switch the f of x, which is the y, switch the y into x, and then use algebra to get y equals again. All right, that's the -1. So let's take, if I gave you 3x squared minus 5 equals y. All right, how would you find the inverse function? Okay, first thing you do is what? Switch the x and the y. So now I make this my y and that my x. Now, I need to get to 1y now. I want y equals. So the first thing I do is what? Add the 5, move the 5. Then I divide by 3 to get rid of that, and then I have to take the square root. I was working with an Algebra II student that I tutor on the side, and this was the problem he had to find on ABCD. He was given this, and the question was, what was the inverse? So it said f -1 of x, that's how you write inverse, equals, and then he had to go find that one in the list of A, B, C, and D. Now what happened, all right, one of the things that was given was that answer. All right, what's wrong with that answer? All right, going back to the original, they subtracted 5 instead of added 5. Right? Suppose that 3, that this was a plus, but the 3 was out here. Then it means that they transferred the 3 instead of dividing by 3. Right? So all those answers that were in that A, B, C, and D were things that you could do wrong as you transform the algebra from one side to the other. Okay? So, now here's the question. Is this an Algebra 2 skill or an Algebra 1 skill? All right. It's actually an Algebra 2 skill that uses Algebra 1 to get it. Because the hardest part is switching the x and the y. If you don't know how to switch the x and the y, you can't guess very easily at what the inverse function is going to be. All right, and so the switching is 2 different skills. You switch the x and y, and then you use Algebra 1 skill to come up with Algebra 2 inverse. Yes?
I have a question. If these are on the test,
That skill is on the test, yes.
Yeah, will it say, like in the instructions, inverse? So
Yes, it will say what is the inverse function for, and then it'll give you an equation.
Okay.
Yeah, no, it's not trying to trick you,
Okay.
but it wants to see whether or not you can do the work once you've been asked to do it. Okay? And then technically, if you're writing inverse function, it's written f of -1. Okay. All right? Okay, conic sections. Okay, I tried to get more conic section equations in the final and lost. So there's not as many as I think there ought to be. But obviously, you should understand how to tell the difference between a circle, an ellipse, hyperbola, and a parabola. How to tell the difference, and you will have to be able to complete the square. All right, what's the major word for completing the square? That you have half, right? So when you factor the number, right, then you take half of the middle term, right, and then the extra number that you're adding, you have to do correctly. Okay.
Are we going to have to graph them on the final?
I don't recall. I think yes, if I remember right. You will have to graph it, but it's not difficult.
Right.
Right. And again, what did I teach you about the ellipse and the parabola? You make the same box, right?
Right. Yeah.
You make the same box. And so, let's see. Let's do this one right here. Let's do this. Let's do this one. Okay, the first thing I have to do is to factor out a 25, right? So that'll make this 25 times x squared minus 2, because 2 times 25 is 50, and half of 2 is -1, so now I've completed the square. However, this has 3 terms in it. The last term is -1 times -1, which is 1 times 25. So I had an extra 25 here, therefore on the other side I got to put another 25 to keep the equation in balance. All right, now let's look at the y. The y, -y squared, all right, that's already there, but when I take out a -1, this becomes y squared minus 6. Now, what's half of minus 6?
3.
X minus 3 squared. Right? Now, what's the third term that I've introduced?
30.
9, I'm sorry, right, negative 3 times negative 3, which is 9 times negative 1. Because I've introduced a negative 9, I have to introduce a negative 9 over there. That's what's different about the hyperbola. Right? Because it's not always adding a positive number. Okay? Now, I also have a 36 here. Right? So, oh, I've got 2 of them. Oh, I see what happened. Alright, I didn't even look. Okay. So this one and this one add up to 61, don't they?
Mm-hmm.
So therefore I have a negative 61. Now, it turns out I saw this problem. This was one of the test problems on the chapter final for chapter 9. Is this going to be a negative number? Negative 61, negative, and positive 20 is going to be negative. So when I divide it, these two signs are going to change.
Yep.
Right? This will become, this is the y, sorry. This will become plus and this will become minus when I get my denominators. And so the plus side is where the graph, the hyperbola is. And so after you do your box, it's going to be top and bottom because you're dividing by a negative number. Right? And like I said, the one problem on the chapter 9 final test, which you've already submitted in, had that problem. I don't recall, this is me honestly, I don't recall which of these is on the test. I don't remember. So, but at any rate, you should still know how to do all 3 of them, all 4 of them, really. You should be able to do all 4. All right, the parabola is actually a quadratic equation.
Yep.
Right, that's one of the reasons why a lot of times I'll say all 3, because we've already worked with quadratics. All right, questions about that? All right. Okay. All right, that's it. All right, now I have to, all right, kill this. All right, I am looking for that the one I just did? Practice, here it is. All right, this is what you got. All right, here's your practice. Okay, now, first question. Not really on the test, but it's something that you should know how to do. Okay, how do you graph the zeros of that function? First of all, what makes this binomial 0? Negative 5. That means I should do this. Okay, what makes this a 0? 4. So what do you have to do? Now, what makes this a 0?
Negative 5.
No. You didn't divide. It's negative 3 divided by 2, which is negative 1.5. Right? See, if this equals 0, I'm going to subtract 3 and then divide by 2. Okay? So that's negative 1.5, which is right here. Now that's a cubic. Right? And so the general shape of a cubic, one of the things that you can see here is negative 20 times 3, negative 60. It crosses way down there. Okay, now, as x gets bigger and bigger and bigger, what's going to happen to the y? It's going to approach infinity, right? So that means it's got to be coming like this, going way down to here. Whoops. Yeah, there we go. All right, and I have 1, 2, 3 slopes. So therefore I have a cubic. Now, you don't have to do that graphing of the cubic, but you should understand that. Now, how would you get the polynomial based on this? That's binomial multiplication, right? All right, that is on the test. You got to be able to take these, multiply them together, and then multiply them by that, and then collect your like terms and come up with a polynomial. I know one thing. What's the first term going to be?
4x. Oh, I mean 2x.
2x cubed, right? 2x cubed. So I know that the first term is 2x cubed, and I just told you the last term was negative 60. Right? The middle terms you'd have to find out by doing the actual math. All right, question about that?
No.
All right, good. Let's move on to number 2. All right, now, solution set. Should be familiar. What I'd like you to do is I would like you to, right now, by yourself, do the problem. Get the answers for this one here. And that, again, that is on the test. You've got to be able to do that.
I think that's like the easiest thing on both.
If it is easy, that means you know it. That's good. That's good. Okay? All right, now when you're finished, are you guys finished already? Okay, you jumped ahead. This is the other part. Okay, well, when you're done, look up, and I'm gonna put it on the board here. Okay. All right, get it? Okay. All right, I got 100% here. You better have it right too. Okay. All right, now. Okay, now it says graph it. Now go ahead and graph it. All right, is there conversation? All right. Okay. All right, now this says x is, what is it? What does this sign mean? X is, I'm looking for a word from you. X is greater than or equal to. All right, so that means if it's greater than, it goes this way. Now, if I read it backwards, it says x is less than or equal, that's going this way.
You gotta fill in the holes.
All right, why do you fill in the holes? Because the equal sign says I got 2 things to do, the circle and the center. So it should look like that, bless you. Open holes, you do not get credit. So if you would have not filled in the circles, if you did everything else right and not filled in the circles, you would have lost it. Yes?
So if it's not equal to, you don't fill in the circle.
That's right. What I see for pre-algebra is that it takes 2 things to be able to make that. Right? This circle is the first. So if there is nothing down here, then you leave it. But if there is, then the second thing you do is fill the circle in. Okay? Right? And the same thing would be true. The same thing would be true on the graph. If there's an open circle on the graph, that means you only do the greater than or less than, but not the equal. Okay? Now, do we have to do domain and range? Okay, domain and range, you start with x such that the set of numbers has an x in the center, right? It has to be greater than and less than. Okay, what's the biggest x value?
13.
Looks like right there. 1, 2, 3, 4, 7, 8, 9, 10, 11, 12, 13. And the lowest one is 2. Alright, so this is a 13, this is a 2. Is my sign right? Can x equal 13?
Yes.
Yeah, it's a closed dot. So what do I have to do here?
Yeah, the equal sign.
I have to put the equal sign in. And what about on this side? I got to put the equal sign in. All right, that's another way of dealing with the same thing with graphing, is that you treat the equal as that bottom sign. Okay, now what about the y? The y would say y's such that the set has a y in the center. Notice. All right, now 1, 2, 3, 4, 5, 6, 7, 8. Right, this is an 8. So it has to be less than 8 and greater than 1. What about the equal part?
Yes.
Why? Why will y have to have equals in it?
Because the circle is filled in.
Because that circle's filled in, right? And that circle's filled in. So therefore I have to put the equals in. Okay. Yes?
So if the numbers aren't given on the graph, do we just like assume that
You assume that the units are 1 each.
Okay.
Yes. Okay. And I pulled this particular chart off the internet. So I happened to see it without, and I thought, yeah, that's just one more thing. Right. If it had the numbers in it, it would just have been easier to do. Right. So I figured if you can do this one, then you should be able to do the one on the test.
Good.
Okay. All right. Now. All right, here is my representation for substitution. Which function or functions has 1, -2 as a solution? Okay, now this is calculator work, so get your calculator out and tell me what you put in your calculator.
For A,
Yeah, for A.
you put
3 times 1 plus 2 times 1 times -2 minus 4 times -2.
That's 9.
Hmm?
I got 7.
Oh, that's better.
Now, Ari, you don't have a calculator?
I know.
To the -2.
All right, you have 3 times 1 plus 2 times 1, which you can eliminate. So 2 times -2 minus 4 times -2. It has to be a positive number.
Just kidding.
All right? And I think you get positive 7. I believe that's the correct answer. Okay, so do we circle that?
No, because
No, that was wrong. Okay, so let's do the same thing in B. Okay, all right, so 2 times 1 is 2 minus 3 times -2 plus 5 times 1 times -2.
equals -2.
That equals -2, okay. All right. Okay. You just got that problem wrong.
What?
You just got that problem wrong. What did the directions say? Which function or functions? We haven't checked the third one yet, have we? teaching you.
Pay attention to the.
Pay attention to the directions, and you always look at the rest of the problems. If there was supposed to be one answer, then that one should have been false, right? And if it was false, then you proved that you found the right answer, right? But what would have happened if you would have ended up with this situation where the last two were both right, but only one of them was supposed to be the correct answer? Then it means that you made a mistake. And God forbid that you don't make a mistake in the first one, because the C was supposed to be the right answer. Right? So always check your work. And when you get into the SAT, that's another way to guarantee that that answer that you're choosing is the right answer. Is that if three of them are false and one of them is right, then do you have to worry about that problem anymore? No, you know you got that answer correct. Okay? All right, now. Okay, this is what I wish was on the test. All right, so what is f of g of 2? Okay, so first thing you have to do is what? Put a 2 in here and get 12 minus 3, which is 9. Then you put a 9 in here.
3 plus 2 is 5.
3 plus 2, 5. Okay.
Wait, so these aren't on the...
You said that one's not on the final?
A problem not as hard as that is on the final.
Not as hard as that one.
Not as hard as that. Again, I lost.
But that was easy.
That was
I know that was, yeah.
I want to do those all day long.
I know, okay, that's good, that's good.
Easy.
I'm glad you like that.
I hope a lot of them are like that.
All right.
Thanks.
Okay, now here's a question. Here's a question. What would have happened if I would have said this?
You put all of G of X.
It's
into
Okay, so what would you write? What would you write?
Square root of 6x minus 3 plus 2.
Square root of
6x plus
6x minus 3, and then outside of it, plus 2. That's what you would write if it were f of g of x.
That's right.
Okay.
I see, I find that harder than the G.
It is harder.
Yeah.
It is harder. It's because it's abstract,
Yeah.
right? When you understand what g of 2 means, then you get a concrete answer here, a concrete number, and then you get a concrete number here. So it's easier to put your mind around it. That is abstract. Some people don't have a problem with it, others semi-struggle, but it is what it is, right? Okay? All right, now. Okay, this is the testable. Okay, so transform that into slope-intercept form. Go ahead, do this problem on your paper before we talk about it. Again, this is good practice. This is going to be on the test. You good? What happened?
I forgot a step. I think I should.
All right, you're gonna subtract an x,
Yeah.
right? That puts negative x on this side, and this zeroes out. Then you're going to divide by -3. So when I divide this by -3, I actually have a 1 here. So that becomes positive 1/3 x. And then when I divide that by -3, I get -4. So y equals 1/3 x minus 4 is the correct answer. Okay.
I forgot the slope-intercept form is just y equals mx plus b.
Yes. Oh, you just wrote that. No.
No, I was trying to figure out what
Okay.
slope-intercept.
All right. Slope-intercept form is y equals mx plus b.
It's
Yes.
been a while.
All right. And again, that. Okay. Why is slope-intercept form important? Because it makes the graph easy to produce. Because you start with whatever the intercept is, and then you go the slope in each direction, and you can sketch the graph relatively easily. Okay? So, after struggling, by the way, there's practice in your book on this, in the early chapters. Okay? Taking this, how do you plot it? Start with a negative foe, and then do what?
Go
Up 1 over 3, up 1 over 1, 2, 3. Now I'm going to do it again. Up 1, 1, 2, 3. And up 1, 1, 2, 3. And then up 1, 1, 2, 3. You put your way out there. Now, question, is that a positive slope or a negative slope?
Positive.
Positive, so I got it in the right direction. And then I would come down this way. All right, now, I've added something different. I said, where does the line y equals -3 connect with the line you just drew? So the question is, what does the graph of y equals -3 look like? It's a vertical line going through what? Going through, what is this? Is that x equals -3? Or y equals -3? That's x equals -3. So if I have a vertical line that goes through x equals -3, I haven't graphed it right.
Right.
Where does y equal -3?
The horizontal.
Right here, it's a horizontal line. And they meet right there at -3, 3.
Oh, it's
Okay. Has to, right? Has to. All right. Now, got some erasing to do. Okay. Now, we've already been through Kramers Rule, so I'm not going to go over it again, but you notice there's some real numbers there this time?
Yep.
Okay, so you should be able to handle that. And if I do that, watch this, if this is the right one. All right, these two go in the bottom of both of them, right? And then I replace the 2 and 11 in the first one, then I replace the 2 and 11 in the y on the second one.
Right.
Okay. And again, these are all things you should do, you should be able to do. And so what will be the denominator? It'll be 3 times -1, -3 minus 5 times 4. -3 minus 20, right? That's -23.
But yeah, where's the -1?
Where do you get 3 times -1?
Oh,
Right,
gosh.
2.
It's a 2, sorry.
So
Okay.
the
Okay.
denominator would be 25 instead, but everything else is the same.
Yeah.
It's like,
I can't do that here, I gotta do that here.
Yeah.
All right, 2.
It's like,
That off.
Oh, that's a bummer. That's the only, I made it. I've got a bunch of, all right, I didn't look at that.
it's reversed.
We'll go through that anyway, so that, my bad on that one. what I did is I changed the problems and to make them a little bit more difficult to do. Okay, so at any rate, I will repair that. Right now the evidence is gone. Okay, so factoring the given quadratics. Okay, now here's a question. Okay, what are the possible factors that go into this problem? They are factors of what number? These are factors of 36. What are the factors of 36? 1 and 36, 2 and 18, 3 and 12, 4 and 9, and then 6 and 6. Right? Okay, can any of those add up to 20 to negative 24?
Yes.
Which ones?
2 and 18. Nope.
36.
Good question. Did you hear what she just asked? Sydney said, where did the 36 come from? 4 times 9. And see what happens in Algebra 1 with Forrester is that you work with 1x squared, and so all you do is break that last number up. Right? And so when you get to the chapter that says harder equations, your skill that you used in Algebra 1 won't work on that problem. Will it? Because you can't break the 9 apart. You're supposed to break the 36 apart. Okay, so that's a good question. And when I teach Algebra 1 out of Forrester's book, we skip the easy ones and we start with the hard ones. So when you get back and all of a sudden you have this, oh, this is easy now, because instead of using 36, all I'm doing is using that, and I automatically know that I have 2 x's in the front. Right? But, and so it's just the approach. But what I found when I taught this is that the students were making an assumption that all you looked at was the last number, because that's what you practiced for 2 chapters, was looking just at the last number. So when you got this, you said, oh God, this is hard. Okay? And I understand that. So first of all, is there a combination that gives me negative 24? So therefore, what do I have to use to be able to get that? Quadratic formula. Okay? Alright, now let's look at the second one. Can I get a negative 15?
Yes, you can.
Yeah, right here.
12.
So therefore, I have a 3x and a 12x. Okay, now what am I going to do with the 4 and the 9 to be able to get a 12? I'm going to have to put 4x here and a 3 here to make that negative to get negative 12, right? Then the front has to be negative 3, so this must be negative 3 and 1. The point for those was that you've got to remember that you use the factors of P times Q. The first one times the last one, not just the last one. Are we that close to done? 19. Oh boy. Got 20 minutes, right?
No, we can add it.
We have 5 minutes.
We have 5 minutes.
Okay, we'll get there. All right. And then the rest of that's it. Okay, now, all right, so here's logarithm. What's the first step that you do if you have this problem to solve it? All right, can you put that in the calculator the way it is?
Nope.
No, therefore you're going to have to, C word, you're going to have to convert it. Convert it to what? All right, into what?
Exponential.
All right, exponential form. So what will the exponential form look like for that problem?
X to the second equals 49.
X to the second equals 49. And Sydney, if you know that answer, you can just write, right? Okay, square root of that, so x is equal to 7. Okay, what's the first step you do in this problem? Okay, where's the x now? The x is the exponent, so what I'm going to have to do is get rid of the base. So log base 7 of 7 times 2x equals log base 7 of 96. That's the first step. That's the hardest one.
What's the exponent above the log base 7?
2x, which is here.
Okay, got it, thank you.
Which is here. All right, log base 7 of 7 is 1, so that means that this is 2x equals log 96 divided by log 7, and then I'm going to divide it by 2 to get x.
So we're going to divide the answer that we get there. by
Yes,
2.
after you get this answer, you're going to divide it by 2 to get x.
Okay.
But again, all I was working for was what's the first step. Now, what's the first step for the last one?
Beginning exponent.
All right, convert it to exponent. When you do, what do you get?
8,
8
2.26.
to 2.6 power equals x, and that's just straight calculator work. Okay. Last question in logarithms. How do you simplify log 4 of 11?
Divide by 4.
Log 11 divided by
That's
log
right.
4. Okay, log 11 divided by log 4. Now, factoring. We went over the factoring before. Well, why did this move? Oh, because I'm at the bottom, that's why. Okay. All right. We went over factoring. Remember that the second part, you have to square both of the terms. All right? Explain the difference in circle. Okay, how do you know you have a circle equation?
2 squared and it's r squared.
Right, both are squared and both are the same coefficients.
Same sign.
Right, okay, and they both have same signs. All right, how do you spell ellipse? All right, ellipse, it equals 1, right? The two numbers on the bottom are the squares of the distances, and they both have to be positive.
Right.
For an ellipse, a hyperbola, right? Equals 1,
Equals
right? The numbers on the bottom are the directions, the square of the direction, and you have to have one of them negative.
Yeah.
All right, and then the hyperbola is just a quadratic equation. Okay? All right, thank you. Now, you are supposed to be here at 8 a.m. on next Tuesday. And what we're going to do, the test has, what we've gone over is the computation part, and then there's a section of true and false, and a section of definitions with a word bank.
Okay. Oh, we're
Wimpy.
I think we should not have
Wimpy.
Sounds
All right.
very wimpy.
No,
Very
so it's
wimpy
very
and
fair.
proud.
Very fair. And so, again, I would expect that all of your grades are going to be fine.
Yeah.
Okay? The only thing I'm going to do is that we're going to be spread out because I want your, excuse me, I want to see your work, all right, and not the work of your neighbor. So if I had a chance, I would have put the order differently so that your test and your neighbor's test would not be in the same order. So you
Could
couldn't
like
grade
at the
for.
same time.
That's how, and when I did finals in public school, if it was a close thing like this, I had 3 tests.
That's
Same problems, different order. So, you know, if you're looking at your neighbor and says, what'd you get for 4? Right? If you circle B, you didn't get the right answer because your test was different than the one you got from. So there's ways to do that. Okay? All right, thank you for a good year. Look forward to most of you next year in college algebra. So listen, college algebra is similar to the work that we're doing and that we've done this year. What college algebra does, it starts with the skills that we're finishing up. And then it adds some complexity. So you're going to have a set of rules that you have to apply to a problem, just like you had sets of rules in Algebra 2 that you applied to your Algebra 1 skills. Right? And so we moved everything up a level. That's why they call it Algebra 2. All right? And then Algebra 3, which is sometimes called pre-calculus, Algebra 3 and the introduction to college algebra is the same skills. Right? And that's the reason for the dual enrollment, is that because the work that you're doing for Algebra 3 is the same work as college algebra 101, why not do them together and get credit, because you're not going to wait 10 years before you go to college.
Right.
Right? And so that allows for the early enrollment, and you be able to get most of your freshman year classes out of the way as juniors and seniors. Okay, so it'll be fun. It'll be a little bit more work, because you're going to have to make sure that you have time during the week to be able to invest in learning the skills. Because when you came into algebra, most of you could slide, because you're pretty good students. And so you slide, you really didn't put any practice, any hard practice into it. When you got into Algebra 2, sometimes that burned you. And you had to go back and spend the time to be able to get the answers right. When you get into college algebra, you're going to have to spend at least 3 hours out of class for every 1 hour in class. Okay? So, because we have a 1 hour class, you're going to have 3 hours of homework in order to be able to learn what you're supposed to learn. Now, I don't think if we logged the number of hours that you did for Algebra 2, I don't think it came up to that at all. But it will. Now, in those 3 hours of college algebra, you'll learn it. You will learn it, okay? All right. Thank you for a good year.
Thank you.
Thank you.